So number one says the exact value of 6 divided by 0.003. What you want to do is to understand that this is what the setup is really like, right? You're dividing 6 by 0.003. But normally what we do is that we make sure that the denominator is a whole number. So that's going to be difficult to work with a decimal there. So you want to do what you have to do so it becomes a whole number. So we'll multiply this by 1, 2, 3, 4. So it's like you move it 4 places to the right. So we're going to have to add 4 zeros to this, right? Turn it into 1, 2, turn it into 60,000. And then from there, now 3 into itself 1, 3 into 2, 6, 0, 0, 0, 0. And we're looking at 20,000 there easily. All right, so you want to convert the decimal into whole number because it's a part of the denominator. Question number 2. Question number 2 says, looking there, 0.0346 written in standard form. Remember, in standard form, the decimal point must come after the first non-zero digit from left to right, which means we're going to have the decimal point between the 4 and the 3. And then it's always going to be times 10. Let us now check to see how many places we move this point for it to get there. We moved it 1, 2 places. All right, so this is going to be to the second. However, it could be negative, it could be positive. If you move from left to right, it's always a negative. Or if the original number is a 0 point something number, then the power of 10 will always be negative as well, right? All right, let us look at number 6 up here. So I'm going with what is on the screen. So number 6 says, express 4 3/3 as a decimal correct to 3 significant figures. So what we want to do is to firstly understand what 3/8. All right, so 4 3/8. You want to know what 3/8 is as a decimal, and you have to make a note to know these, the 8s. You need to know them. So 4 3/8 is 4.375, right? But what they want is 3 significant figures, which means that we're going to be rounding this up to that spot. So when you identify the spot, you want to make sure that you look to the digit to the immediate right. And if the digit to the immediate right is 5 or more, the spot goes up by 1. So it's 4.38. So here it is for that one, right? Number 7. What is the highest common factor of the set of numbers 54? So we're talking about 54. We're looking at 72. You're looking at 90. Factors, all right? The fact that we're talking about factors, these two are out, right? Because the factors cannot be bigger than the numbers that we're seeing. All right, so you're looking at 9 and 18. Which one of these could go into these? And you're going to realize that 9 could go into these as well as 18. But because we want the highest one, we're going to have to choose 18. Because 18 could go into this about 3 times, and it could go into that about 4 times, and this about 5 times. So 3, 4, and 5. Yeah. So 18 is the highest common factor there. All right, let's look at question 3. Looking at this one. Question 3 says, express 0.12 as a fraction in its lowest term. So this is a number with 2 places of decimal. We can rewrite this as 12 over, and the number of digits behind the point will tell what type of number we're dealing with, right? So as you could see, it's going to be over 100. Why? Because these 2 places of decimal, they're referring to the 100th place. So we're going to have to put it over 100. Now, this is not there because they want this in its lowest. You can take your time. Let us say we want to use 4. 4 into the 12 goes 3 times, and 4 into 100 is actually 25. So I'm looking at 3 over 25. All right, let's look at number 8. All right, so number 8 there says -1/2, right? to the third. Now, please bear in mind that negative a half raised to the third power really means that negative a half will multiply by negative a half, and then it's going to multiply again by negative a half. So we want to understand that the power means how many times you will be multiplying this thing here by itself. So at the top, we'll get a negative 1, and then we'll get 8. So the response we're looking for is negative 1/8. All right, let us go to number 4. Take a look at number 4, right? Now, if you look at number 4, it says the square root of 17 square minus 15 square. You can go ahead and square the 17 and square the 15 if you want, but I'm not going to approach it like that right now, right? I'm seeing the difference of 2 squares going on there, the difference of 2 squares. So I could rewrite this as, because this is a difference of 2 square, 17 square and 15 square, I'm going to factorize this. So I'm getting at 17 plus 15, and then 17 minus 15, because the root of 17 square is 17. The root of 15 square is 15. So as you could see, under my square root, I'm going to have 32 times 2, which is 64, right? So the square root of 64 is 8. So there it is. I would have picked 8 like that. So sometimes you could look and understand the things first. If you see the difference of 2 square, factorize it and move on. It saves you a lot of time. All right, let's look at number 5. It says John, Peter, and Mary shared a sum of money in the ratio 2 to 4 to 9. So we're talking about 2 to 4 to 9, right? So always label your ideas so that you have enough information to go forward. John and Peter together received 360. So then we want to isolate this, but watch the question. How much money was shared? So we have a number of approaches to this question, a number of you. One of the approaches is that we want to take note of the ones that we got. So we got for John and Peter, the total. So we're talking about 6 parts, which they told us was 360. So from here, I could definitely understand what's going on. So if I divide that 360 by 6, I'm going to get one part to be 60. Now, if I know that one part is 60 at this time, I could find the total. I could find the total by adding up these, and this is going to land me about 14, right? So if I multiply the 60 by the 14, I'll get that answer. That's one approach, all right? Hold on, let me see if it is 9 plus 4 plus that, 15, all right? This is 15, my friends. So by 15, so if we multiply this by 15 and type 35, okay, I'm seeing 900 here, all right, which is this. And another approach is that you never had to do that. What we could have done was we could have found the 9 and add it back to the 360, right? So another way that we could have done this was that we could have said, all right, we know that 360 is gone already. We could say 9 times the 6, and this is going to give us about 540. And then we could add back this to it, and we're still going to get that same 900. So it depends on what you want to do or what you see, right? But definitely the clue that was given here was the fact that they gave you Mary and Peter's total. That's the clue, all right? So you don't want to mix it up right there. All right, let's look at number 9 right here. All right, so number 9 says, what is the value of the digit 2 in 48.621? The moment we approach the decimal point, I will highlight here. We're going to be in the decimal world. The first place of decimal is a tenth. This is a tenth with a TH. The second place is 100th. And the third is 1,000. And it goes on, as you know. But the TH, so 100th. So the 2 would be simply 2 over 100 as a value. Right? So it's 2 over 100. All right, let's look at number 10. So number 10 says, by the distributive law, 49 times 17 plus 49 times 3, you could factorize out that 49 and you'll get 17 plus 3. And so you're getting 49 times 20. And this would have been the response right there. All right, let me look at 13. All right, question 13 says, in which of the following Venn diagram is the region A intersect B complement? So they want us to look at A intersect B complement. Now remember that B complement is everything outside of B, everything. But we don't want everything. We want the part that is mixing with A. So we want the B complement that mix with A, not all of the B complement, because this part means that. So when you see that symbol there, it's talking about the intersection or the part that is sharing with A. So let's look for that. And I like C, because when you look at C, B complement would have been everything except B, but they want the part that coincides with A. So you could see that this is the appropriate one, or the only one, right? All right, let's take a look at question 11. The shaded region represents, as you could see, the P is not touched, all right? So everything is shaded except P. This idea is called the complement of P, hence you'll see this little thing here. So it means the complement of P. So it's everything except P. Everything except P. Let's look at number 14. All right, number 14 says set A, talking about factors of 3, B, prime numbers less than 10, and even numbers less than 10. And then we're going to be looking at an idea that is included in all. So it depends if you know these things straight up, but you could write down the factors of 30 right here. Factors of 30 are numbers that could go into 30 without a remainder. So like 30, 15, 10, 6, 5, 3, 2, 1. So those are actually the factors of 30. Prime numbers less than 10. First prime number will be a 2. Then we have a 3. Then we have a 5. We have a 7. So those are the prime numbers. Remember, prime numbers only have 2 factors, one on itself. And then now lastly, even numbers less than 10. 2, 4, 6, 8. So we're looking for an idea that is involved in all. And you're noticing that number 2 is the only idea that is in all. So we're talking about A intersect B, and it still intersects C. What is common for all 3 sets? And that is number 2. All right, let's take a look at number 12. In the figure above, X represents the set of multiples of 4, right? So this X is the multiples of 4. Y would be the set of multiples of 5, right? Then the shaded region could be 1. So we want to list our multiples of 4. 4, 8, keep adding 4, or your 4 times, 16, 20, I'll stop at 24, and it goes on to infinity. Multiples of 5, right? Multiples of 5 would start 5, 10, 15, 20. And I'm seeing something already, right? You could see that this part would be what is overlapping, right? What is overlapping? lapping. And definitely the numbers that are there, 20 is the answer, right? So you could see that 20 would be a part of the multiple of 4 as well as a part of the multiple of 5. Discount of 10%. The amount of the discount is what, right? All right, remember now, 10% is always to just take off a 0, right? So 10% is to take off a 0. Since they want the amount for the discount, it's just $18, right? The amount of the discount. How much would have come off? Drop off a 0 at the back and you'll get your 10% immediately. All right, we're still working. An article bought for $125 was sold for $175. The percentage profit is what? For the percentage profit, you're going to have to subtract your cost from your selling. You're going to get $50. And you want to represent this 50 over the cost, then times it by 100. So you're talking about your profit over what it costs you, and you turn that into percentage. All right, so the rest is to work down. I'm going to use 25. All right, so 25 into this 2, 25 into this about 5, 5 into this of 1, 5 into 100. It's going to give you 20. 2 times 20, I'm getting 40. All right, so I'm getting 40. All right, let's look at number 19. Number 19 says, in reference to this table below, we have house insurance, we have contents insurance. So for the house insurance, it's 25 cents per 100. Very important. Per 100 is very important. Contents, 50 cents per 100. So what we want to do is to look. So let's say we're working them out one at a time. If the house, right, is valued at 50,000. So I'm able, first what you want to do is to find out how many hundreds you'll get in 50,000. So you divide this by 100. You could see you're going to get 500. But remember that it is 25 cents per 100. So I'm going to get the 500 times 25 cents. But 25 cents is actually a quarter of a dollar. So I'm able to work out my dollar value now by simply dividing this by 4. 4 into itself 1, and 4 into that about 125, right? 500 divided by 4, you get about 125. So for the house part, it's going to be $125. For the contents, I'm going to still try to find out how many hundreds do I have in 10,000. I have 100 in 10,000. But now the contents is going at 50 cents. 50 cents is what? A half of a dollar. And that is why in the multiple choice, they're going to be using specific numbers. They're not going to use any number that will give you trouble. So as you could see, a half of a dollar. So this is 50. So you want to add that 50 with that, and I'll get 175. There is the answer. So that would have been the, total insurance that the person would have paid when you work it out. And if you look back at the question, you will note that they are not just going to give you any random number. They are selecting numbers that you could easily relate to and flow. And remember that 25 cents is quarter of a dollar and 50 cents is half of a dollar. So you could easily break the numbers down right there. All right, for number 20, it says Tom bought a pen for 60 and sold it for 20% to gain 20% on his cost. How much did he gain? Now, the question is not asking you how much did he sell the thing for. They're asking you how much did he gain? He gained 20%. So there are two ways you can work this out. One, you could say 20% of 60. Can do it that way. 0 cancels 0 and 0 cancels 0. 2 times 6 is 12. So you could look for your 12 right there. Another way you could do it is to understand that if I have any money, 10% is to drop a 0 off. So this is equivalent to 10%. That means 20% is to double. Oh, that means the 6 double, I'll get 12. So you could see, yeah, I mean, you could relate to it the way in which you feel most comfortable. But 10% is actually a good way to go. The questions will be set up in such a way that you can easily drop a 0 at the back to get 10. And from 10, you can find 20, 30, 5, 2.5, 1.25, and the list goes on. All right. All right, let's look at item 24. Let's pay attention. It says item 24 refers to the information below. I'm seeing X dollars for the pen, Y dollars for the box. The total cost for 3 pens and 2 bucks. So you want to put together the idea, 3 pens, 2 bucks, total. So I'm going to look for 3x plus 2y. And here it is. But you have to make sure that you pay attention to the details, because if you flip around it, look at that. There is a nice distractor. So X is for pens, and you need 3 pens. You want to make sure that you're not making any error right there. 21. Mary invested. So we're saying here 21. Mary invested. I might need a little space. All right, I just wanted some space to work. So so the question reads, right? So here's the question now. All right, good. So the question says that Mary invested $200 for 3 years at 5% per annum. John, 300 at the same rate, which is for 5%, he went. And they're asking, how long will it take John, since they both get the same interest? All right. So what you could do, you could line them up side by side if you want. You could say, this is Mary and this is John. What is simple interest? Simple interest is equal to P times R times T over 100. That's one approach. So you could say for Mary, 200 times 3 times 5 over 100. And this should equal to, for John, 300 times the 5 times the T. We don't know what the T is, over 100, because they're asking us for the time. So what we want to do is to break this down. Look, we're canceling. Look, you're canceling. On the left side, you're having 30, and you have, on the right side, you have 15T. What could T be such that you get 30? And everybody would look and say, oh, 2 times 15, 30. Or you could divide by 15, you'll get 2. So 2 is the response for that. But you want to make sure that you set up a nice idea so you're not guessing what to do. All right. So whichever way works best, you go. All right. So we picked that. Next question says, a woman buys a pair of shoes at a sale. She pays $60, saving $15 on the regular price. All right. All right. So she saved $15 on the regular price. The percentage discount of the shoes is what? Right. So take a look at this. Read it. She buys shoes, all right, on a sale. She pays this. But when she pays that, she saved $15, right? She saved $15 on the regular price. All right, so the percentage discount that you want to find. This is her discount. That is the discount that she got. But here's the trick. You have to understand the original, you know. All right. If you want to work out discount, let me put it like this. It's your discounted amount. let me put this, amount over, I'll say your original price, your mark price, let's go to the original, right? And you multiply this by 100. This is how you would have found that. But what I'm saying is, if you're gonna work out this, we know it is $15 she saved, which means this is the discount. You can't put it over 60 right now. If you put it over 60, you're going to be in problem. And why you're going to be in problem is that 60 is not the original price. She pays 60, save that. So in other words, and go back to what she really saw the thing for. She saw it for $75. So she saw it for $75. They took off 15 and sold her for 60. That's what the question is saying. We want to interpret that to understand. And then now you can just turn this into percentage if you want. All right. And it's a quick thing to do right there. All right. So 15 into itself 1, 15 into 75 is about 5. And then you could go 5 into itself 1, 5 into 20. You're seeing 20. Right. So you're seeing a 20% there. So, I mean, there are a number of ways that you could do it. Another way that you could see the 20, first, though, you're going to have to make sure that you understand that it's coming from $75 and not 60. All right, $75 was the real deal, right? So then, you know what 10% is? I'll say this to you. Take a look. 10% is the journey to the left. Move your decimal point one place to the left. 10% right now is $7.50. See it there? 10% is $7.50. That mean you could see for yourself, if you double this, you get 15. 10 and 10, 20, 7.5, 7.5, 15. Oh, so it is still 20% various ways. It's up to you to look. But I think the 10%, the amount of time I see them using it, you can always relate to 10% quickly. If you don't see it, fine. But that's always a very good option. All right, let's look at 25. So 25. Let's go for 25. All right, so 25 says that we want to distribute this. So where do I distribute this? I might have to take this somewhere else. I need a little space. All right, let me just bring this to my other screen quickly. All right, here we go. All right, there it is. All right, so what we're looking at here is that. All right, so I'm saying that you want to quickly distribute, right? Let's do our distribution. So we're going to distribute. You could just do that quickly. Look to see what you have. It's up to you, right? So 3 times a will give you 3a squared. 3a times a is 3a squared. 3a times b would have given you 6 with the ab. Negative b times 2 is negative 2ab. Negative b times negative 3b is positive 3b with a square. So as you could see, this part becomes positive 4ab. All right. So we're looking for the 1c. If you're not careful, you might make a mistake because look at this right here. This is the answer, right? This one is the answer. But they do have another one very similar, but the sign is different at the back. And we realize that it should be a positive at the back, all right, when you're done. So take a good look at that. The answer is B. All right, so the answer is B for that one. All right, let's go. 26 says, given that A asterisk B is 2A minus 3B, right? Then 2 asterisk negative 3. I'm saying that always set these up, set them up. And you can do a quick substitution. Make sure that you're following your algebra. So if I'm going to do 2 asterisk with a negative 3, I'm going to make sure that I understand that the A is like the 2 and the B is like the negative 3. So let's follow. 2 times A is 2, minus 3 times the B, right? What is the B? The B is negative 3. So what are we looking at? You're looking at 4 plus 9 and that is definitely 13. And our answer is here. If you don't pay attention, we can easily get the wrong one out. All right, so there it is. The answer is 13. Use substitution. Link the ideas together. No rush. It's never a rush. You have 90 seconds per question, and some of the questions will take you a few seconds. So you'll have to spare. All right, so you have to just take your time and go through. Let's look at number 23, then we go 27. All right, so 23 says here, -2. We want to distribute that, so we're going to have -2 with an x and then a +8. So we're looking for that. The answer is D. Regular algebra they're testing for now. All right, testing for regular algebra right there. All right, so let's go. Now 2, and then in bracket. Now this one, I think this one tricked a lot of people, so you have to be very careful. This exponent here, this power, only affect what's inside. The 2 is by itself. So what you want to do is to have your 2 weighting. However, what we're going to have here is that you're going to have a to the 6th and b to the 3rd, right? Remember, when a power is raised to a power, you multiply powers. And then now at the end, you should be looking for 2a raised to the 6th and b to the 3rd. And I'm looking at b here. Be careful not to just pick, you know. Remember, when a power is raised to a power, you multiply. For example, if you have a to the x, and that is now raised to the y, it really means a xy, not x plus y. Power to a power, multiply powers. Big difference, right? All right, we're continuing. All right, let's look at 28. So 28 says, given that 2x plus 3 is greater than or equal to 9, the range of values of x. We're going to solve this ordinarily. Remember, whenever you're solving inequalities, it is done just as how you would have done an equation, except if you multiply or divide by a negative number, all right, then the sign flip. So if that is not happening, you just work ordinarily. So we're going to subtract 3 from both sides. So what do we have? We have 2x, which is greater than or equal to 6. Then we divide by 2, divide by 2, and then you could see that x is greater than or equal to 3. Then you look for your answer. I'm seeing this as my response, and it's right there. All right, so you take your time, you work your thing down, and then you see what's going on. All right, we're going to 29. All right, 29 says, given that 3, an open bracket, what do we have? X minus 1, and then -2, x minus 1 equal to 7. We want to solve. All right, so we're just going to have to clear this up. So let's distribute 3x minus 3, then minus 2x plus 2. This is where the issue is. -2 times -1. That's a +2, and this is equal to 7. On my left side, if I group my ideas, I'll have 3x minus 2x, and then I'll have a -3 and a +2. All right, just showing clear. So this is x already, and this is -1. This is equal to 7. So you're going to have to add 1 to both sides. X is 8. All right, so we're looking at a value of 8 there, and we're good. So we have to take our time when you're going through these. Let's look at number 30. As you can see, we're in the algebra section. John has X marbles and Max has twice as many, right? So John has X. So you could say, John, that's X. Max must be 2X since he has twice as many. All right, good. Max, now we're told that Max gave John 5 of his, right? How many marbles does Max now have? Talking about Max, you know, all right? Now, let's focus on Max. So Max originally would have 2x after the first information that was given right here. Then now, he said that Max gave away. When you gave away, you're subtracting. So you want to look. So this is where the question stops. So it is 2x, and it gave away 5 from it. So you want to look if you see that, and definitely the answer is here. All right, so 2x would take 5 from that, and that's what Max would have now. 33. the volume of a cube whose edge is 6 cm. Again, almost every year I tend to see this question. So a cube, all the sides are the same, right? So you're talking about 6 times 6 times 6, and this is gonna give us 216. 6 to the third power is 216. All right, let's continue. 34. 34 says, the figure above, not drawn to scale, shows a sector of a circle. The length of PQ is 8 cm. So I'm gonna put the 8 here. What is the length of the circumference of the entire thing? A number of ways we can do this. I always say that I could try to complete this circle. So if I try to complete the circle, I want to see how could I split this up equally? 6. So you want to say, how many times can 60 go into 360? We're going to get 6 times, which means that this extends, we have that. So we have 60 there, you have 60 there. You have 60 here, you have 60 here, you have 60. Each time you get 60, you're getting an 8 cm. 8, 8, 8, 8. So at the end of the day, you're going to have 6 times 8. You're going to have 8 6 times, and the answer is 48, right? So we want to just, appreciate ways in which you could flow. Not saying that this is the only way, but definitely it's a very simple way to see how many times with the 6 goes into the 360, and every time it goes into it, you're getting a circumference of 8 centimeters, which would have given you it 6 times, and finally 48 is the response right there. Let's continue to roll. Number 31. Number 31 is focusing on this question up top here, right? So it says item 31 refer to the diagram. We have a rectangle. We see 2 cm for the width and x minus 4 for the length. The area of the rectangle in cm is x squared. All right, fine. So the area is x squared. No problem. The equation that may be used to find x, I'm saying that what I want to do is to put together my knowledge. I'm thinking of, if I want to find the area is always length times width. What's my length? It doesn't matter how you want to put it. So you could put 2 times x minus 4, right? I could look, if I see this should equal to x squared. If I see this, it is fine, and I'm seeing it. So I wouldn't want to go any further. All right, it's there. So in other words then, the length times the width must equal to what they claim to be the area. And we were told the area is x squared. So length times width is equal to that. And we got that, so we move on. All right, so we move as we go. All right, let's look at 35, then we look at 31. All right, 35 is saying that the distance around the edge of a circle upon is 88. So here is my circle upon, right? So what they're telling me is that the circumference is 88, right? Because the distance around the edge, right? So you're telling me that, hey, the circumference is 88, all right? And the question went further to ask for the radius. So what we want to do is to set up what we do know. We do know that circumference is equal to 2 pi r, right? Now, I was told that the distance along the boundary was 88, which means that 88 is equal to 2 pi r. My intention is to find the r, so I'll divide both sides by 2 pi. 2 pi. First thing I want to do is to stop here and look, because I have already isolated the r. R is equal to 88 over 2 pi. And if I'm seeing this, it means I'm done. And definitely, it's right there, right? 88 over 2 pi. As you can see, they're not trying, right? It's not like they're trying to see the value. They want to know if you can put this together, right? If you're just coming on the video, Please like the video. If you have not yet subscribed, please subscribe to the channel, all right? And take note here, on June 11th, we're gonna be doing a 9 to 5 marathon right here. Not on YouTube, though, it's gonna be done through Zoom, live Zoom. So if you wanna be a part of that, contact this number here, all right? And it's gonna be a 3-phase. 2 phases we'll be teaching, and the last phase you'll be doing a real paper one in the time allotted for it. And as you click submit, you'll be getting back your results immediately. So you want to see exactly where you are. And the platform that I'm going to use to do the test is going to help me to see immediately the questions that were done the worst. So I could, in the last session, as the test is finished, I will be able to see the errors that were made commonly, and I will be able to address it immediately before the session ends. So be a part of it. It's going to be good. All right, let's go. Number 36. Number 36 is saying here that item 36 refers to the diagram below, right? And it says we have a 12, so this is a square and we have a rectangle. All right, cool. Which of the following statement is true about the perimeter of figure A and B? Well, what I'm going to do, I'll make sure that I finish this off. So I'm seeing 48 for this, and I'll definitely work this one. So 16 plus 16, that's 32 plus 9 plus 9, 32, 18, this is 50. All right, so that's 50. All right, good. So right now I know that the perimeter of B is bigger. So I'm going to be looking for that. They are not equal. Perimeter of A is greater, no. That's a false thing. Perimeter of A is greater or equal, no. But perimeter of A is smaller than B, yes. So the perimeter of A is smaller than that of B, and you pick that and you move. So you spend time work out what you have to work out. Please look at what they're asking. All right, I'm gonna go 37 and then I go back to 40. We're gonna go 40 to 42 after that. So 37. I might go 37, 38, 39 as well. So let's go. 37. The length of the sides of a triangle are as follows. So why not just drop your triangle, your scaling triangle. So we have a X. Oh, it's an isosceles, right? So we have a 2X, we have 2X, we have X. So the length of the side X, and if the perimeter is 20, all right, what is the value of X? So again, having a diagram is always very, very important. So you're talking about adding up. So they're testing to see if you know what perimeter means. It's the distance along the boundary. So I'm going to be adding up X plus 2X plus 2X, and this should equal to 20. All right, so it is 20 because we got that distance. So then we're talking about 5X is equal to 20, right? And then I divide both sides by 5. So you can see that X is 4. So we're looking for that, and it is right there. So they're testing for ideas to see how well you know the regular stuff, all right? So put it together. Perimeter is the big deal here. This is the big deal, understanding the perimeter, and then labeling off the things so that you could have a clearer vision of what you have to do. And then they gave you a numeric value for it. Set up the expression, let it equal to that numeric value, and then the rest is algebra as you find your X. All right, let's go to 38, 39. So 38 says the area of a rectangle is 53.6. If the length is multiplied by 4 and the width is half, the area would then be what? Now, we're saying that we understand that length times width does give us the area of a rectangle. And this was 53.6. So what we're suggesting is that if this is half, right? So we were told that the length was multiplied by 4 and the width was half. All right, then Each time you make a move, this will be affected. But if we are able to cancel the 2 into the 4 2 times, you are now seeing that all that happened on the left side, the going up by 4, coming down by a half, you're going to see that the result is 2 times LW, which means that I have to have 2 times this to get my final answer. All right, and I'm going to get 107.2. Right, when you multiply that by 2, 107.2. Right, so sometimes let's apply yourself to the idea, look to see what you have. All right, let's go. 39. 39 says each exterior angle of a regular polygon measures 45. How many sides? All right. What we want to do is to understand this idea. It doesn't matter how many sides you have. The total exterior angle is always 360. If you have 100 sides, when you add up all the exterior angles, it's going to come to 360. If you have a triangle, you add up the exterior angles, 360. It doesn't matter. Total exterior angle is 360. All right, which was one of the questions that just came the other day. Understand? 360. So what you want to do to understand the exterior, if I have a triangle like this, just to show what it is, this is an interior angle. The exterior angle is to extend any one of the sides and you go outside, right? So we're saying that these are what we call the exterior angle out here. That's exterior, and this is the interior angle there. So I'm saying the total exterior angles all the time will add to give 360. So then if I want to know the number of sides, if I have a regular polygon, and this is a very powerful word here, it means that all of them will be the same. So if I divide 360 by 45, it's going to tell me how many sides we have. You're going to have 8 sides. So this is the way to go, right? What you want to understand is that the total exterior angle of any polygon is 360. It doesn't matter. So if I know that angle out there, and when they say regular, they're telling you that all the angles are the same. When it is irregular, I couldn't do this. If it were irregular, I could not work this out. But because it's regular, I know that every one of the angles would be 45. So that means if I divide 45 into 360, it will tell me how many sides I have. Or in other words, I want to say this to you. The number of angles tells the number of sides, right? So what this is basically telling me is that I'll get 45 8 times. I'll get 8 of those 45 angles, but every side is linked to an angle. So it simply means that 8 sides would have 8 angles inside. For example, a triangle, 3 sides, 3 angles inside. A quadrilateral, 4 angles inside, 4 sides. So you could know, right? So there's a direct relationship with the number of sides and the number of angles that you have, right? So when I find this, I understand that I have 8 sides. All right, let's go to 40. So 40, 41, and 42 will be coming from this one diagram. So the question reads, it says the item 40 to 42 refers to the diagram below, which shows the sports chosen by 160 boys who participated in a game evening at their school. Now, 160 boys is crucial. We want to make sure we have that down. Let's see what the first question is. The number of boys who chose football is, as you can see, football is actually 90 degrees here. It's a quarter, all right? So all you have to do is to understand that, hello, there's a direct relationship. Football is a quarter. So then I could take a quarter of this, right? A quarter of it. No, right? It's about 40. So divide by 4, I'm getting 40. So we're talking about 40 of them will be for football, and I'm looking for 40 right here, right? So no big working yet. You understand? No big working. We're able to see the angle and then use it. Next question. The probability that a boy chosen at random participated in boxing. Boxing. Now look, the direct relationship between boxing and football is that boxing is half of football, right? 45 degrees to 90 degrees. Oh, half of it. So that means that the number of persons would be half. So it's 20 persons we're dealing with right there. So if I'm dealing with 20 persons for boxing, 20 out of how many? There are 160. 20 out of 160. Let's cancel. 0 is gone. 2 into itself, 1. 2 into 16, 8. So I'm looking for 1, 8 as my answer, and here it is. All right, so there is my 1, 8. Right, good. So next movements, right? Next movements is 42. It says how many boys participated in cricket. Let's go back to that. How many boys participated in cricket? All right. Now, all right, this is a nice one to look at. I see something that they're getting at here. All right, let's fill out. If we have 160, right? And we're looking at, hold on. All right, so we have 160 overall. Let's put 160 so we could nail. This line here would be a half again, as well as if I take it this way, I'm seeing a half again. Understand? Or I would understand that this is 45 as well. It's up to you. There are so many ways. That means this is 20. That means this is 20. I'm seeing that because this is the same 45 here, just the same, right? So we're seeing the 20, we're seeing the 20, you're seeing it's the same. So all you have to do is add those up and take it from 160, right? So we're talking about 100, let's add it. Talking about 40 plus 20, that's 60, plus 20, that's 80, plus 20, that's 100, all right? So then we're talking about 100 minus. So it's gonna be 160 and you take 100 from it and then you're left with 60 here, all right? So you have to look, take a good look again. Cricket, here is cricket, right? This is cricket and we're having where it is 60. We're saying that you could use the information. Remember that you got 45 here. They told you that this is 90 right here. So that means the next little piece is 45. Oh, so if this is 20, then this is 20. And you're seeing vertically opposite right there. Look at that right there. So whatever I have here is the same here. Understand? That's also this 20 is the same 20 here based on what's going on there. So you are able to put things together, sort it out, and work. Nice working. We have to focus. 43. 43 says, which of the following is not a statistical diagram? Diagram. So this is a diagram. This is a diagram. This is a diagram. This is not a diagram, right? Modal class is an idea, right? It's not a diagram. So we have that. 44. 44 says a bag contains 2 red, 4 yellow, and 6 blue balls, right? The probability of drawing a blue ball is what? Probability is everything over the total. Our total is 12. Blue is 6. 6 out of 12 is not there, so we look to cancel, and we're seeing 1 over 2. It's a half. 44 is a half. Let's go to 46 right there. All right, so this one says item 46 refers to the arrow diagram below. Please look at where the arrow is pointing. The arrow is coming from X to Y. We're gonna eliminate. A lot of times you're gonna have to eliminate things that are not so that you can see what is, right? So the arrow diagram above describes the relation. So there is a relation. Let's see what the relation is. Let's go. X is greater than Y. Let's look. 2 to 4, X is greater than Y. No, it's not. The moment I see one thing that is off, it messes up the entire thing already. So the x values is not greater than the y. Next one, x is a multiple. If x is not greater than y, count the multiples. X is a multiple of y. All right? No, x is not a multiple, all right? Because it is smaller than y, it's not a multiple. X is divisible by y. X is divisible by y. So in other words, then you're suggesting that 2 divided by 4 will give me a whole number. No, it is suggesting, so no. So x is not divisible by y. So this is also incorrect. So that means this is the answer, whether or not I read it. And this is how we want to understand what we have to do. I'm going to read it though, but the answer is already the last one. X is a factor of y. Okay, let's take a look. Factor. That means it should be smaller and it can go into it. All right. Or it should be as big as itself. For example, can 2 go into 4 without a remainder? Yes. Can 2 go into 6 without a remainder? Yes. Can 3 go into 6 without a remainder? Yes. Can 4 go into 4 without a remainder? Yes. Can 4 go into 8 without a remainder? Yes. Can 5 go into 5 without a remainder? Yes. So definitely. But you wouldn't need to do it because they put the correct answer at the back and you actually eliminate the first 3. So when I eliminate the first 3, I'm not going to prove the last one. I'm just going to tick it and go. All right. Let's look at 45. 45 says, item 45 refers to the table below, which shows the frequency of scores obtained by students in a test. So here is the score at the top, and we're talking about the number of students. So 8 students get 2, 4 students got 3, 6 students got 5, and it goes on. So the question says the modal score. Modal score. So which one of these occurs the most? So we're looking here, we got 12 students, right? So the score for that way, because a lot of people would have picked 12. No, you will be incorrect. 12 is not even data. 12 shows how many times a certain thing was seen, right? So the modal score is 8. We saw 8 12 times, right? All right, that's 45. We did 46, so we go to 47 right here. All right, item 47 refers to the figure below. We're looking at that. Let's put it up. It says the gradient, right? The gradient of AB in the figure above is what? Remember that the gradient can be calculated by using rise over run, right? Gradient can be calculated by using rise over run. So it means then if I have a slant line on any grid, I am able to pick off a right angle triangle, so you could see it right there. That's a decent right angle triangle. Gradient can be calculated by putting your rise over your run. And in this case, we want to note that all lines that move from top left going up a hill, for example, not top left, if the line shaped like from left to right, you're going uphill, it already will tell you that the gradient must be positive. Negative gradients would be coming downhill from left to right all the time. So I know that this is a positive gradient already. Rise, how many units am I looking at going up? That's 2. How many units coming on horizontally? That's 4. So you want to set up 2 over 4. Cancel down by 2. 1 over 2. Positive 1 over 2. And that's my answer for 47 right there. All right. Let's go to 48. 48 says the arrow diagram below shows a function. All right. So if you look, you're seeing a function right there. So 48, you're seeing a function. What the question wants. Which of the following best describes the function? Look, you want to look at all of these and see which one. But at the same time, you could look if you are able to see what's the relationship between every x to its respective y. I'm seeing I'm adding 3. I'm adding 3. I am adding 3. I am adding 3. So it works. So x plus 3 is the answer. A. 49. The range of x to the third for the domain negative 2, negative 1, 0, 1, 2 is 1. Guys, substitute, right? X to the third, substitute. So you're going to substitute negative 2 to the third, then negative 1 to the third, then 0 to the third, then 1 to the third, then 2 to the third. You're going to substitute these values in the function. This is negative 8. This is negative 1. This is 0. This is 1. This is 8. So you go and you look for these. You work them out, and then you look, right? Remember, though, you know, negative 2 to the third means negative 2 times negative 2 times negative 2. Hence, this is how I got the negative 8. Negative 1 to the third is negative 1 times negative 1 times negative 1, right? And that is how I get negative 1 at the end. So the answer is D. Number 50, coming down, it says, if A, B, and C are constants, the equation of the graph could be what? Now, firstly, your quadratic curve could shape two ways. One, it could turn like this. Two, it could turn like this. Now, when your quadratic curve opens up, like this one here, it's a case where your A value is negative. And A is negative because we say that the curve frowns. So when A is negative, your curve will frown, like a frown face. When your A is positive, your curve smiles, like a smiley face. So right here, looking at this curve, it is smiling. So I already know that I am dealing with a positive A, which means it cannot be B, it cannot be D, because those are carrying some negative A's. So you have to look and understand so you can know where to go. Now it's either A or C. Now, if you look at A cannot come off the y-axis. A cannot come off the y-axis, and I could show you. We could go and look. Look at the format. It's A x squared plus C. So it could be any number. So it could be any system like you have y is equal to, say, 2x squared plus the number. This type of thing will not move off the y-axis. So you could look, it's always going to be on the y-axis. So we could take a quick look here. All right, let's take a quick look right there. For you to just see the point I'm making. Just going to show you what I'm saying. Let's take a quick look. Watch. Y is equal to, could make up any number. We could say 2x squared. See, it is on the y-axis. Take a look. I'm not done. I'm going to add a number at the back. Look what's going to happen. Plus 5. So if I put plus 5, it is still on the axis, but it moves to 5. Now, I'm going to be changing this number at the back. I'm going to show you that it's not going to leave off the axis. I could put minus 6. Enter. It's going to go down to 6, but I'm still on the y-axis. Look. So when it's shaped like this, whenever you don't see, and let me tell you what I mean, what I'm getting at. Whenever you see y equal to square, and this could be any number. This could be any number right there. And then this could be any constant, just a constant. The moment it's set like this, it is always on the y-axis. When it shifts from the y-axis is when you will get some dx. The moment I introduce this, it will start shifting off the y-axis already. All right. So as long as this comes into play, it is coming off the y-axis, whether it's going to go to the right or it's going to go to the left. All right. So I could show you what I mean. Watch. I'm going to just let this be negative 6x. I'm going to put the x on it and watch it get off the axis. See that? It came off the axis the moment I just shifted. See there? It walked off the axis. Let me put it back on the axis. I'm going to take off this x here. Take it off. It's going to go back on the axis. Go back on the axis. And that's what we're saying. So we're talking about understanding a quadratic form, right? So the moment you have the square, so the idea is the square, focusing again, this part. Doesn't matter what number is A. This is on your y-axis. And even if this is another number, as long as it's just a constant, there is no letter attached to it, it's good. When you're gonna get off the y-axis is when you're gonna have to introduce a B value. That means you're gonna have some 2x, you're gonna take off the square, but the x will be there, right? So let's do it one more time, change the number. So it's not, so we're very confident in what we're doing here. Let us say this is, say, 3x, right? 3x, enter. It's gonna walk off the axis. See, it shifts off the axis. I could push it further. Maybe plus 9. So let's take a look where it is now. See that? It's shifting to the right. So we're suggesting that, take a look at this. You could see that this came off the axis. It might touch the axis going up, but we're talking about this pivotal point here, the axis. So with this one at A, it's going to be on the y-axis, like you will see it on the y-axis, like that. But you see this one at C, the one at C is when you introduce this. The moment you introduce this, and even if you don't put on this part, the moment you put on this part, you're going to step off the y-axis. And that's the answer, all right? So you want to kind of understand those. First, you want to understand when the curve turns up, when it's frown, when A is negative, when it smiles, when it turns down like this, when it is smiling like this, when A is positive. And then you want to understand that if you have just an x square, that is going to be on your y-axis. You'll see it on the y-axis like that. Even if I put numbers at the back, it's going to be walking up and down on the y-axis. When I want it to shift to the left or to the right, I have to put an X here. So you're looking for those sort of stuff to see what's going on there. All right. So I hope that made sense to you. All right. We're continuing. All right. So we're going. 51. Which of the following represents the graph of a function? Talking about a function. Now, the concept of a function is that the concept of a function, if I should take a vertical line, right? So there are two concepts. One has to do with taking a vertical line test. So with this one, I could do the vertical line test right there. All right. So let's take a look. All right. So if I'm going to do a vertical line test, if the vertical line touches 2 points or more, it's not a function, right? If it touches 2 points or more, it's not a function. So if my vertical line will just touch 1, then it is a function. So I could go for a vertical line here. All right, so we could be using this line. Now, as I move this line, look, if I put it down, it's only touching 1 point there. If I move it, 1 point still. If I keep moving it, you will see it will only touch 1. Now, if I go for another, look at this vertical line. It's touching more than 1 point already. See for yourself. Touching more than 1 already. Touching 2, that's not a function. It's touching 4. That's not a function. It's touching 3. It's not a function. So what we're saying is if I use a vertical line and it's touching more than 1 point, they are not a function. So this is no function. No, it's not a function. No, it's not a function. Yes, it is a function because it only touched 1 point at a time when I have that vertical line. So the answer is A. So vertical line test is very good to test to see a function, right? Vertical line test, remember that. Now, if they don't give you a vertical line, let me say that they didn't give you a vertical line and they give you a number of points. how do you know functions? So if you have some coordinates, right? Watch this. Let us make up some set of coordinates. I'm going to make up some set of coordinates. So we're going to tell, all right. So let us say I have one with 8. I have 2 with 9. And then I see 1 with 10. Now, the fact that number 1, this is a system. This is one system. The fact that I see number 1 with 8, and then I see number 1 with 10, it's not a function. Each x value just should have one y value. The x value should just have 1 in itself. And we're saying that you can have 3 x values with 1 y value. That's fine. But each x value must only have 1 y value. So let's take a look at this. Say I have 3, 4, and I have 5, and it is 4, and I have 6 with 10. This is a function. Why it is a function? Even though I have 3 and 5 with 4, they are separate. So it's not like I'm seeing 3 with 2 values. No, I only see 3 with 1 value. I only see 5 with 1 value still. Unlike, so this is yes, a function. This is no, because I'm seeing number 1 with 2 different values, and that's the problem. All right. So we want to understand it from a diagram perspective as well as from a coordinate perspective. All right. So you could look out for those. Let's move. All right. So we're looking at 52. This question comes a lot. It says item 52 refers to the diagram below. All right, of a construction. And this is always a 60 degrees, guys. Take note of it. The 60 degrees look like this. You'll see this. Please take a look at that. That's a 60 degree. All the time they'll give this, if they're going to give it. All right. Sorry about that. 52. 52 says, what is the measure of angle BAC? Oh, we just did that. All right. My bad. 60 degrees, right? So let's look at 54 on the screen. 54 says, a ship sails, this is a bearings question. Let's take a look. A ship sails 8 kilometers due east, right? 8 due east. So I could make my own thing and then match. So it sails 8 due east. So this is 8. Talking about it went that direction. So we did that from A to B. It then sailed 6 due north. To C. Which diagram below best represent the path? I'm going to be looking for this. So I'm going to go to the right to B and then 6 up. So 8 to the right to B and then 6 up. We're looking for that, looking for that, looking for that. And I'm seeing it. Here it is. Right here. There it is. We went to B and then to C, 8, 6. So you want to always have your visual. You want to always have yours and then you look for theirs. If not, you look to see if an error was made or anything. All right. But you want to be very simple as well as very precise. It says item 53 refers to the right angle triangle below. All right. So we're looking at that. All right. So we have 5, 12, 13, and we have an angle right there. All right, fine. All right, let's see what they want. It says in the right angle triangle above, tangent 90 is what? Tangent of theta is what? Tangent. So you want to remember that this is coming from tower. Tangent of theta. Tangent is opposite over adjacent next door. So you're talking about the tangent of the angle is going to be 5 over 12. So I'm looking for 5 over 12. And here is my tangent. All right, remember, do not let this trick you. For example, this is the right angle, which means that the hypotenuse will be directly, you know, opposite to it. So that's different. This is the hypotenuse. We don't want to mix up that. All right. So adjacent, opposite in context of that angle. All right. So opposite 5/12, and we're gone. All right. We're going 55. So 55, it says here, it says that the image of the point -2, 3 on the translation, 3, 4 is what? So again, object plus translation gives image. Object, -2, 3, I have to put it in a column vector form to suit the translation, 3, 4. -2 plus 3 is 1. 3 plus 4 is 7. So the coordinate I'm looking for is 1, 7. Definitely at the back here. All right, so you're seeing that. Let's go to 57th here. Question. In the diagram above, I'm reading this one. In the diagram above, the vector that translates PQ to P prime Q prime may be described as what? I would say to you, you want to make note of identical points like P to P, and that should do it. What if you don't like that letter P? Well, you could focus on Q to Q. It's up to you. All you have to do is to focus on one pair. It's going to be the same movement, so you do not need to do two. Now, what are the principles that you need to focus on? Here is the guiding principle for the motion, the movement of a vector. Now, the first movement has to be horizontal. Has to be. And horizontal motion could be going to the right or going to the left. So if you're going to the right, it's a positive number. But if you're going to the left, it's a negative number. We want to make note of that. The second motion, that means after you have done your first motion, there's a second motion to finish the job. The second motion is a vertical. It's always the vertical that comes second. Now, and it has to do with the bottom number. So we're talking about X, Y, right? So the horizontal is X like the X-axis, and the vertical is Y like the Y-axis. So now, if you're going up, it's a positive number. And if you have to go down, it's a negative number. Now, if I am at Q and I intend, if I'm at Q and I intend to go Q prime, I have to think. Remember, I have to move horizontally first. Do I move to the left or to the right? If you decide to go to the right, you'll realize that you will never line up with your Q prime. So you can't go to the right first. You have to go to the left. Count the number of spaces based on the scale that you have. So this is 1, 2. That means my top number is a -2 already, because I have to step 2 places to the left to line up underneath. And then I'm going to step 1, 2, 3 up. That means it's a positive. So what we're suggesting is I move to the left. I will highlight now. I move to the left from my top. So that is my negative. Hence, I get -2. And then I move up. That's a positive vertical. That's why I get +3. So we're looking for a -2 with a +3. And that, so you only want to see the relationship between one pair. You don't have to do all two, because it's like a waste of time to do that. So let us now mark that -2 with a 3, and here it is. All right. In the diagram above, AB is parallel to EC. Calculate angle BDE. Now let's mark the angle first. BDE. from B to D to E, this. Now, this is a nice idea. You can do it a number of ways. I'm going to give you two approaches. One is to understand that if I have two transversals, if I have two parallel lines that was cut by a transversal, then a lot of things are going on. Now, if I'm inside the parallel lines, inside, and I'm on the same side of the transversal, so I'm inside the parallel line and I'm on the same side, I'm to the left of that line, I could use co-interior to link the 40. This will be 140 because co-interior angles add to give 180. So I'll take out this and I'll get my co-interior angle that links to that 40 would be 140 degrees. This would be the answer. Now, let us say I never knew about co-interior angles. It means that I would have to do something else. For example, I could have done this as well. I could have used alternate angles and relate the 40 here. Same thing, what Z angles are equal. You're seeing the Z. Now, I am now on a straight angle. And a straight angle measures 180 degrees. All right, so then I would have to say 180 minus the same 40, and I'll get back the same 140, because this would have been the straight angle that I took the 40 from to get the 140, same answer. So it's up to you if you want to go there, all right? So there are two approaches. Pick the one that works best for you, depending on the question anyway. 58, we're coming down. It says 58 refers to the diagram, right? Blue. It says in the diagram above, CAB is 35. It is there. And angle AC, no, and AC is the diameter of the circle, right? They want us to find angle AD and B. I'm going to mark it ADB, AD to B right here. Guys, semicircle was given here. This was given as a diameter, which means that this angle is 90 degrees here. So that means I can find that. And whatever this angle is here, same segment would have gave me what I want, right? So then I'm going to find that third angle, right? Angle in a semicircle is 90, so that is how I'll get 90 here. So then I simply could say, if I add that 90 and that 35, I'm going to get something like 125. And then now, if I take 125, right? 180 minus the 125, I'll get 55. So if I take the 180, yeah, you get 55. And angle in the same segment will be equal. So if I find this angle, I automatically find that. So the answer is 55 degrees. So guys, put together everything because here's the circle coming out. The only thing is that they didn't ask for any reason. All right. But they can give an answer and ask for the reason. All right. 59. A plane is heading in the direction of 45 degrees and changes course in a clockwise direction to 135. The question is the angle through which the plane turns. Let's take a quick look. All bearings are from the north, and this is the underpinning idea. So if my first bearing was on a 45 degrees, it simply means that this angle here was 45 degrees. Now, they're suggesting that the plane is now gone 135. 135 is going to come all the way down this section. But where does 135 come from a bearings perspective? Still comes from the north of the point here. So it's going to go all the way here. 135. So 135 would encompass that 45 and go on some more. The turn, though, you would have realized that the plane was heading here and then end up heading here. So the turn in focus will just be right here. That's the turn. Turn is just that little piece right there. Right there. So now if I have these two angles and they do overlap, then if I take back that 45 out of that 135, the turn was just a 90-degree, was a 90-degree turn. So I look for that. Done. Last, the diagram, it says in each of the diagrams shown below, A prime, I think they said A prime there, is the image of A. All right. So, all right, good. So A is the object. Which of the diagrams shows a reflection in the x-axis? Well, you could look for yourself. X-axis is right here. This is the x-axis. And A reflected and give you this. Definitely. So the answer is B. You look at it, you're seeing the reflection in the x-axis. That is number 60 right there. Believe it or not, we finished exactly